So now let's try a little bit larger and compare and see what happens. So remember, we have our first curve, the blue curve, where eta was 10 to the minus 5. Then we have the cyan curve where eta was 50% larger, so 10 to 1.5 times 10 to the minus 5. And now I tried even larger parameter. So this is the red line. This is eta equals 2.5 times 10 to the minus 5. So this is 2.5 times bigger than the blue line. And what we see bigger oscillations in the beginning, and that early oscillation phase goes on for a long time. As you see, the oscillations are decreasing towards the end, decreasing, but we still picked a parameter that was too big. We started to see the oscillations is not converging. There's a gap, significant gap in the likelihood function, L of W. So the red one, 2.5 times 10 to the minus 5, is too big. So let's understand a little better why those oscillations come about. So if I were to use the blue, very smooth step size, what happens is I start from the starting point and I take these little steps and I'm kind of following this nice smooth curve all the way to my desired parameter W hat. If you pick a step size that is too big, I look at a gradient here and it's looking pretty good. Direction in the beginning. So let me change colors there just to make it super obvious. So I'm going to use green to denote this step size, which is too big. So I start here, I find a gradient direction, but I take a step that's too big. Boom! I went to somewhere really far away over here. So it took an eta that was too big. And now I compute the gradient here, and it's in this direction. And boom, I took a step size that was too big. I ended up over here. And then I compute the gradient and I get something in this direction. And boom, I take a step size that is too big. I end up here and I take a step size that's too big, and so on. And you keep oscillating back and forth with these really big steps. Now, in this case, in the red line, 2.5 times 10 to the minus 5, you see these oscillations are decreasing, so eventually it's going to get closer and closer to W hat. But you have to be careful. Now let's see what happens when we pick a eta parameter that is too large. What I've done here is taken a much bigger parameter, so I picked eta, which has a step size 10 to the minus 4. Remember, the other ones were ordered 10 to the minus 5. As you can see, they're increasing. This is 10 to the minus 4. So 10 times bigger than this blue line here, which is eta 10 to the minus 5. First thing that you observe is wild oscillations. This parameter is too big. Things are going everywhere. Doesn't seem to be converging. And the likelihood value is much lower than of the other parameters. The other way to look at it is, look, we thought that the difference between the red parameter, which we thought was too big, the blue parameter, which was better, or the cyan one, was a big gap. But look at the gap between this all curves look really small because we had to make that scale much bigger to show this wildly oscillating one. So 10 to the minus 4 was too big. So here's what I've learned. We've learned that 10 to the minus 6, too small. 10 to the minus 4 is too big. Now we have a range between the too big and too small, and we can search in that range.